Hello, so this is Felix coming to you from Stony Brook University. Today we're going to go over a problem facing mesh current. So the first thing that we want to do is to define how many meshes are there. So as you can see, there's one mesh, two mesh, and three mesh. Notice that they're all in the same direction. They're all in the clockwise orientation. So we're going to name this mesh 1, mesh 2, mesh 3. And then we're gonna come up with the mesh equations. So I'm gonna analyze them from the left side to the right side. And in the first mesh, we're gonna have this voltage source, independent voltage source. So then, since it's going in from the negative sign, so I'm gonna assign it negative 40 volts. And then we're gonna go through the 2 ohms resistor, and then that will be plus 2 ohms, and then the current that goes through it is I1, so I1, and then added by 8 ohms because there's an 8 ohms resistor over here, then multiplied by I1 minus I2. And then we're gonna move on to the second mesh. Just forgot that the equal to 0. And then we're gonna move on to second mesh where we have I2. Well, I'm gonna do it this way. Okay, so I'm gonna start here. So I'm gonna have 8 ohms multiplied by I2 minus I1, and then it's going to be added to 6 ohms multiplied by I2 again. That's the only thing that's attached to the resistor. So then it's going to be I2. The current is going to be I2. And then we're going to have 6 ohms, the one over here, if you can see, the one over here, multiplied by I2 minus I3. And then that will equal to 0. If you notice something is that if, let's say, a resistor is between 2 different meshes, so I'm going to get rid of that. So I'm going to get rid of this thing, and this thing, and this thing. So if you notice that if, let's say, the resistor is between mesh 1 and mesh 2, when we're writing the equation for mesh 1, and when we're dealing with the 8 ohms resistor, it's going to be the mesh that we're currently dealing with. So mesh 1, the current in mesh 1 minus the current in mesh 2. And then let's say if we're dealing with the second mesh, then we're gonna do the second mesh minus the first mesh. And then it's always going to be multiplied by the resistance of the resistor. So moving on to the third equation, or the third mesh. Again, I'm going to do it from this point forward. So over here, just so if you're following, I'm going to start with 6 ohms multiplied by, since we're starting with the third mesh, we're writing the equation for third mesh, then we're gonna start with the third mesh's current minus the second mesh's current, and then that's going to be added by 4I3. Again, that's the only current that's attached to the resistor. And then since we're entering from the positive side, we're gonna have positive 20. And then again, that's going to be equal to 0. So now I'm gonna simplify the equations a little. So let's see. We're gonna have I'm gonna add them together. So you have negative 40. I'm gonna drop the units just so that it doesn't look as messy. We don't have like a bunch of alphabets. Plus 2I1 plus, well, yes, plus 8I1 minus 8i2, and then that equals to 0. And then we have our second equation where we have 8i2 minus 8i1 plus 6i2 plus 6i2 minus 6i3 equals to 0. And then we have our third equation, which simplifies to, if we add them together, 6i3 minus 6i2 plus 4i3 plus 20 equals to 0. And then if we further simplify them, so we add the like terms, and then bring the constant to the other side, etc. We're gonna have the first equation as 40 because I brought it to the other side. Okay, so if you see sign changes, that means I brought it to the other side. Equals to 10i1 minus 8i2. Okay, and then the second equation, which equals to 20i2 minus 8i1 minus 6i3, which equals to 0 again. Okay, and then the last equation simplifies to, so I'm gonna get rid of this to the other side, so negative 20 equals to negative 6i2. Okay, and then, all right, so 6 plus 4 is 10 plus 10i3. And then let's see how we're gonna solve the systems of equation. So there's 3 variables and we have 3 equations, so that's good. I'm gonna substitute everything in terms of I2, so then I can plug everything into the second equation. And let's do the third equation first. We're gonna have 10i3 equals to 6i2 minus 20. I nearly just add this to the other side. And then for the first equation, we're gonna have 10i1 equals to 40 plus 8i2. All I did was I added this term to the other side. And then we're gonna plug them into the second equation, which I'm gonna give myself a little bit more space. So 20 I2 minus 8 times 4 over 5. That's if so now we're gonna simplify the equations. So everything is in terms of I3 equals 2 and I1 equals 2. So we're gonna have I3 equals to 3 over 5, because 6 divided by 10, and then I2 minus 2. And then we have this equation simplifies to I1 equals 4 over 5 I2 plus 4. Okay, let's see, and then we can plug everything into a second equation. So again, we have the second equation here. We have 20 I2 minus 8 times, so that's I1, right? So then 4 over 5 I2 plus 4. And then we have that subtracted by 6 I3, where I3 equals to 3 over 5 I2 minus 2. And then from here, we cannot forget that that equals to 0. And then if we simplify it one time, it's going to be 20 I2 minus 6.4 I2, and then that's gonna be 4 times 8 is 32, and then minus 3.6 I2 plus 12, because the negative and the negative becomes positive. And then if we combine like terms again, we're gonna have 10 I2s equals to 20. And if you do simple division, we know that I2 equals to 2 amps. So we found I2, and then we can simply find I1 and I3 using the equation over here. So we can do, actually we will use these ones because they're already simplified. Sorry, these were the simplified ones. I apologize. So then what we can do is we can solve for I1 first. So we have 40 equals to 10 I1 minus 8 I2, which is just 2, where we get 40 equals to I1 minus 16. Yes, 16. And then we have 56 equals to I1. There's a 10 here. Sorry, there's a 10 here. And then we have I1 equals to 5.6. And then we can solve for I2 here. I3 here. And then it's going to be, again, let's look at our equation. We have negative 20 equals to negative 6 I2 plus 10 I3. So then we have 10 I3, right? And then we're gonna subtract that to the other side, equals to 6 I2 minus 20. And then let's see. So that's just gonna be 10 I3 equals to 6 times 2 minus 20. So then it's going to be 10 I3 equals to 12 minus 20, where we have 10 I3 equals to, let's see, that's going to be negative 8. So then I3 equals to negative 0.8 amps. Sorry, I forgot the unit here. And then from there, we know the current in each mesh with mesh current. Now we gotta find the power that goes to each of the voltage source. So we have 40 volts here, and then we have the 20 volts over here, right? 20 volts over here. So we have 2 voltage sources. Let's see. So we know P equals to IV. That's the power equation. And then we know that we have 40 times negative 5.6 equals to negative 224. And then we have 20 times negative 0.8 equals to negative 16 volts. And for those of you wondering why I made 5.6 negative, is because if you look at the mesh over here, I'm gonna clean this picture up. It travels from negative to positive, so it goes in the negative and goes out the positive. So usually positive currents goes in from the it goes into the positive terminal and leaves the negative terminal. So if it goes in this way, it's going to be positive. But then if it leaves from the positive terminal, then we deduce that the current is negative. That's why I negated it over here. So then we know that a total of, let's see, 24 volts minus 16 volts, which simple addition, that's just going to be 240 volts. That's the total power generated by these two power sources. If you want to double check, you can do power check with all the resistors. It should add up to 240 volts. I'm sorry, I forgot that there's a part 2 of the problem. So to find V naught, we have to use the formula that V equals to IR. And then we know that V naught equals to its current, so I naught multiplied by R naught, which is just 8, as you can see over here. So V naught equals to 8 times I naught. But what is I naught? So we know that the current goes in from the current always goes into positive. So let me erase this diagram over here. So if we look at the diagram over here, we see that the current enters through the positive terminal, and we define the current as going clockwise. So the current is going into the positive terminal in I1. So it will be positive. But in I2, it's entering through the negative terminal, so it's going to be negative. Now we can define V naught as 8 ohms times I1 minus I2, because I1 is positive, I2 is negative. I naught equals to 8 times 5.6 minus 2. And then we can write V naught equals to 5.6 minus 2 is 3.6. V naught equals to 28.8.